And welcome everybody to the Daily Space Weather. Today we're talking about the arrival of a coronal hole wind stream, as well as some anomalies in the total electron content. We'll get to it. First thing we're doing is looking at the sun in ionized helium, 304 angstroms from the Solar Dynamics Observatory. And we've got a high-speed stream of solar protons arriving at the Earth geospace right now. It showed up about, 10 hours ago or so. And it's from this coronal hole right here we see in the southern hemisphere, just ahead of sunspot 2829, which is this bright region right here. And coronal holes are known to blast out material, solar protons, hydrogen nuclei, in this case at about 550 kilometers per second. Pretty fast speeds from our closest star here. By the way, here's a diagram of the solar system. There's where things will be in a week. Here's a star chart. You've got Jupiter and Saturn up there near the ecliptic, as well as the moon having just risen. Also, don't forget to check out our cosmology segment today. We'll be talking about the annular eclipse that's coming on Thursday. The 10.7 centimeter radio flux now at 81 solar flux units. Yes, the sun puts out radio frequency, folks. It comes out of the upper chromosphere and the lower corona. It's the most proportional data set we have to sunspot number. Here's the one-year chart of the radio flux. It's this black line. The red line below it is the sunspot number. And we're just over 50 sunspots in the sunspot number here coming most recently. That data is from solon.info/solar, by the way. And we saw a brief period of geomagnetic unrest already. Since then, fairly calm conditions, geomagnetically speaking. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. Next, looking at global seismicity. What earthquakes have been occurring? Well, here's a 90-day chart in a bar graph form, a very convenient feature of volcanodiscovery.com. And here we're sorting by magnitude. We did see a 4+ magnitude here 11 hours ago near Calipatria, California. And a series of 4 magnitude quakes around the Pacific Rim here. No quakes over a 5 magnitude here, nothing in the 6 range. Looks like 4 5+ magnitude quakes in the past 24 hours. Let's scroll up the list here from United States Geologic Survey. One of those 5+ magnitudes was at the Mid-Atlantic Ridge, the southern portion of it there. And if we miss anything you'd like us to cover, just leave it in the comments. Perhaps we'll talk about it at a later time. Deep quake at the Mariana Islands, near the deepest portion of the ocean. That 4.7 magnitude quake at 248 kilometers depth. One of the largest quakes of the past 24 was this 5.1 at the Philippines. So pretty calm as far as earthquakes over the past 24. 4.4 magnitude deep quake at Argentina. Indonesia saw one of the largest quakes of the past 24. That's a 5.3 magnitude at nearly 200 kilometers depth. That would be more like a 5.6 if it was at the surface. And a deep quake here at the Virgin Islands. And the Caribbean is not a place you don't see any deep quakes. We do indeed see deep quakes in the Caribbean area. That's only a 3.8 magnitude, but at 107 kilometers depth near the U.S. Virgin Islands. Let's just take a quick look at the location of that one. North of the Virgin Islands was the location of that deep quake. Let's see what volcanoes have been erupting. Suminose-jima is on the list. Flight level 090. It's a 9,000-foot ash plume above the Ryukyu Islands as Suminose-jima exploded. Explosive activity also continuing at Coronal. Fuego indeed exploding as well, producing a 14,000-foot ash plume over Guatemala. Sangre exploding as well. 20,000-foot ash plume over Ecuador from Sangre. Revenador, 14,000-foot ash cloud there as the other Ecuadorian active volcano explodes. Sabancaya exploding in Peru. 24,000-foot ash plume as it produces continuous ash emissions. And Nevados de Chilean, sporadic puff emission, reminding us to not pole vault the caldera. No matter how much of a track and field star you are, and no matter how much Steve Stimpak is your idol, please do not pole vault the caldera. We need the views, so don't go out and kill yourself by attempting to do something foolish, like pole vaulting an active volcano. This public service message brought to you by smAsho.com, because a lot of people are stupid. Next, looking at the GOES X-ray flux here. There's a 3-day chart, no major solar flares. And the long wave X-ray flux here is at a background level of B as the sun ramps up a little bit here into cycle 25. No spikes in the proton flux, no coronal mass ejections currently being shown. And here's the GOES magnetometer. We're seeing quite low levels here of GOES magnetometer readings over the past about 8 hours. And let's take a look at the heliospheric current sheet. Now that we've showed you 3 days of GOES magnetometer data, here's what's going on with current sheet polarity. It's the current sheet, the top view ecliptic plane field plot. Part of the National Sunspot Observatory, by the way. We call it the Gong 2 data. Potential field surface source lines. And it looks like the North Pole current sheet has evaporated, at least from the Earth portion of the solar system, I'll say. Here's the latest image, and you can see Earth now just in a South Pole oriented current sheet. Don't be surprised to see this change again, as there is some activity rising in the southeastern limb of the sun. We'll show you that later in the video. Here's a line of sight animation of the same data. It also shows you the solar magnetogram. And you can see quite a few areas of a little bit of magnetic organization there on the magnetogram. Also, we'll show you the coronal hole line of sight plot, which shows you the sun's B field. Those blue potential field surface source lines are the sun's B field. And the toroidal field on which you live is essentially the net effect of the overlap of the north and south solar polar fields, shown here in green and red. And you can see that coronal hole, the one that's providing the current increase in geomagnetic activity via a stream of high-speed solar protons. Second coronal hole rotating in as well. This one down here. And the one on the north has receded a little bit. So the main features that we see on the closest star are coronal holes and sunspots. Is there a relationship between coronal holes and sunspots? I'm believing more and more as time goes on that indeed there is. And of course we do see more equatorial coronal holes around the time of solar maximum than around the time of solar minimum, as at solar maximum the sun is in the process of a polar field reversal process. Great view here of the coronal hole down here on the detected coronal holes. And you can see sunspot 2831, which we called yesterday, now in its setting mode. So we're going to see a little dip in the sunspot number here, it looks like, as 2831 and 2827 and 2830 all set later in the day today. You can see this brief period of geomagnetic unrest in the 3 hours preceding midnight universal time between June 7th and June 8th. Since then, calm conditions at a KP of 2. And for you new viewers, the KP index is a measurement of global geomagnetism. Next, checking out the real-time solar wind. And we see the standard signature of a coronal hole wind stream. We see this increase in the solar wind density, followed by a decrease in the solar wind density at the same time as an uptick in the solar wind velocity. So the density made it up to about 33 protons per cubic centimeter. That's now off of the back of the real-time solar wind there. That was about, the peak was around 33 protons per cubic centimeter. And you see this dip down here. Looks like the peak of the solar wind speed may have already happened here at around just under 550 kilometers per second there. The highest reading that we've seen in this coronal hole wind stream. We don't expect this one to last super long, as it's not that big of a coronal hole. Anyway, current conditions are solar wind density 4.5 protons per cubic centimeter, solar wind speed just under 500 kilometers per second. And the rest of the data here, the BT/BZ, the phi angle, and the temperature are all fairly uneventful over the past 24. Here's 4 hours of geospace magnetosphere movie. We show this daily on the Daily Space Weather videos because the data is not visible in archival format yet. And you can see a fairly steady magnetohydrodynamic pressure here over the past 4 hours. Magnetohydrodynamic pressure shown in nanopascals, courtesy University of Michigan. And yesterday we saw some significant magnetic anomalies on the ground-based ground magnetic perturbations map. And we're seeing a bit of this today once again also. Some pulses coming out of the Pacific Ocean. I'm going to let it play through a second time once again today. And like the last geospace magnetosphere movie, this is also 4 hours of data. I would also note this area right here is one of the strangest places in the world, folks, as that is the area where the Atlantic and Pacific Oceans must equalize their water pressure. A very strange portion of the planet, as water sloshes back and forth between the Atlantic and Pacific Oceans as a result of pressure gradients. Next, we're going to talk about electrons, which have the capacity to charge up satellites. And we see a little bit of that going on once again here over places like Central America. Some minor charging hazards. Here's a 1-year chart of the electron flux. The Earth is surrounded by electrons. And there is a graph of that. Here's a 3-day chart. And oddly, NOAA is actually forecasting an increase in the electron flux here. I would tend to disagree with this, but here's a 3-day chart. Here is the forecast. I would say my forecast is actually down here, expecting slightly lower levels here until this coronal hole wind stream subsides, then a major uptick. So I'm going to say my forecast is more like that, a bigger range for the electron flux over the next couple of days. And I've paused the total electron content forecast here on these anomalies happening in the over the southern Atlantic Ocean near Antarctica. We see some major blobs of high-density electron regions there. And since electrons are very light in mass, they give us insight into what's going on with Earth's magnetic fields. For electrons to be down there in those densities, there's some anomalous magnetic field behavior happening, as electrons are the first thing to respond to things like magnetic fields. Again, because they are so low in mass. That's part of the reason why we view the electrons, because it gives us insight into what's going on with Earth's geomagnetism. We do see some anomalies here. I'm going to let this play through a second time as we see some anomalies here, some nighttime electron flux blobs. You're looking at the electron density for the entire air column from a GPS satellite at tens of thousands of miles altitude, all the way down to your handset on ground level. Here's a diagram of the Van Allen belts and so on. Distances are shown here in miles. Here's another diagram of the atmosphere, distances shown in kilometers, to show you the F ionosphere layer over there on the right side. It's located at about 300 kilometers of altitude, and here is the one slice of the atmosphere the F ionosphere layer, which is looking a little bit anomalous as well here. We're seeing fairly disorganized vibrational regions. And each different color graduation here represents 1 megahertz or 1 million vibrations per second. 1 million oscillations per second is a megahertz. A little bit anomalous looking in the ionosphere today as we approach the solstice, the June 20th solstice. There's the current image, looking a little bit anomalous here. You can see odd shapes to the discharged portion, although the sun-facing portion pretty normal on that image. And it's time for bonus features. The first bonus feature is the Udaipur ground-based solar observatory, located in Udaipur, India. And you're looking at 6,562.8 angstroms, one of the emission spectra of hydrogen gas. We do see some filaments here, such as this one. And you can see some sunspots as well. Continuing on to look at the latest intensity gram. So the main sunspot here to focus on is this one, and it has certainly degraded. I don't remember the numbers. To quote Einstein, never memorize something you can look up. Anyway, there's the full disk intensity gram and the full disk magnetogram. We're going to see a dip in the sunspot number here unless this turns out to be a sunspot. And currently, it does not appear to be. We don't see any ombre. Before we close things out, I'd like to thank our patrons. Thanks, patrons. Please consider giving Smash staff a raise, as Smash staff gets a percentage of our Patreon take. Thanks for donating, increasing the probability these videos will continue to exist and remain publicly visible. If you'd like the earliest updates and more, like multimedia, become a patron at patreon.com/smashamash and give Smash staff a raise. We both need a raise. And we'll close things out with some more additional imagery of the closest star. Here's the sun in 131 angstroms. Some great imagery there. Here's 94 angstroms, another ionized state of iron. And most of the AIA imagery from the Solar Dynamics Observatory are ionized iron spectra. 94 and 131 angstroms both take 10 images per minute instead of only 2, the highest temporal resolution offered by the Solar Dynamics Observatory. And last but not least, here are sunspot, I don't remember which numbers. I think they're 28, 27, and 28, 30. Fantastic close-up of those. And we'll close the video out at 94 angstroms. Thanks for tuning in, folks. Remember to stare at the sun. Attempt to understand the physics. Don't drink it. If you do, don't drive. I don't really care if you drink. Just don't drive. Don't drive even if you're sober. No matter how much I like you, I don't want to see you as traffic. Anyway, we out. Thanks again for tuning into the Daily Space Weather, and may that solar wind be at your back.